Hi everyone, here's Simone from the studio. Welcome to this new tutorial. This time we build something with those multiple pop. Last tutorial was about attribute. I saw a good reaction from the community about the tutorial, so this time we're going to use this knowledge to create tubes, a lot of them. Okay. Now they're not noisy, then you can see that there are some stuff happening, like the head are respecting the colors of the trail. We have some well executed the topology, and we can of course like noise them, and the cool thing is that they move, but the head stay attached. I think there are some stuff that's making this looking homogeneous, we can say. Okay, this is the network. This is the network. Start to be with a bit of computation. The whole thing is sucking half a gigabyte, kind of compact. And yeah, so let's start first to have a look what is happening here. May also right here. So here we are actually generating some point. Okay, and maintain rotate. So this is like pointer. Is head. Then so we're actually creating the head of this rail. Yellow. Okay, and there is one operator colored in red, which is a point generator pop with a certain number of points. This certain number of points is really important. We will discover it later. Okay, then you're like offsetting the point with a cool, is different from noise. So if noise point, it's a sort of, it's a scalar noise. The 3D can be applied as vector. It's a bit different. I don't know if scalar is pretty much correct, but there is a difference between a noise and this cool 3D. Cool 3D is a more like, say, animated version of this noise. Right? We're spreading the points so to do not edit the same axis. Here, they are in the same axis. Then we are rotating them. I'm used to prime numbers to have the spin each time different. Okay, then we are training those thingy here. Okay, by training them, I am then adding an attribute. Okay, this attribute is for the size. As you could see, let's just see the tubes. Very big tubes. The tubes, when they have a thickness, okay, which we can define. See, they are sort of thickness here, and so we can set an attribute for it. This is produced here. Okay, this guy. I'm using a pattern. This pattern has an easy in and easy out. Meaning is like a sweet curve, let's say it's a smooth curve, not sweet, smooth, pardon, okay. So it's using this, easy up, easy down. I like it. This thing here, which is a pattern pop, okay, is then have some parameters set it up, and we are outputting the result of this pattern as a new attribute called size. Okay, so if you go here, you have no size. I am middle mousing on the pins or alt right click. Here we have no size. This guy is creating the size, which is a float. Okay, very important. Then I am like applying this size into a noise. Why? because I want to move the point of the train, but respecting the head basically. Okay, if I don't noise it, they stay. If I noise it, they move. But the noise is respecting the pattern. How is respecting the pattern? Because in every pop, in a lot of them, you can apply those magical array called attribute as a lookup for every parameter. So the parameter is not anymore just one number, can be a lot of number, one per point. You can do it here in the map page. They start to be fancy, I know. So in here, we have the element drop down string menu. This guy allow us to read attributes which are in the point class. Okay, why it's here should be okay. In the point, it allow us to read the attributes from an operator, so we can even have buffers. Crazy. But we can actually read those attributes, okay, from this in here, which is our input, okay. We can read those attributes. Beautiful. So I want to read the one called size. So then I can map this attribute for each point, and I want to affect each point differently with this noise. Okay. So I can then apply this size pattern to the amplitude of this noise. And if you do so, magically here we have something written in constant. 0 equal size. So this is 0. You can even add some stuff that will be added to the incoming attribute. So now we are mapping the size for each incoming point to the amplitude parameter. Bananas. Okay. Remap the size is because I may want to have anyway control over the size, but after I use it. So this, if this would have been here, then I would affect the noise displacement of the point. At least I then do it after, so I can add control to the actual size without affecting the noise. Bananas. Okay. And we need some magical stuff. Okay, why do we need some magical stuff? Because this part now we build together, which is the fun part. Okay, so let's build something like, let's build a tube. You can do a tube by creating a tube. Hey, bravo, Simo, you just did a tube, but we like procedural stuff. So we now create a tube from a line. We take a pattern. Okay, we have a line, a beautiful sinusoid. Very nice. The pattern, so when you drop it and there's no input, it's not noising stuff, it's producing P and a texture apparently as well. So it's producing a point. It's an effector, but can be also a generator, both. And we're generating a line with the 100 point. This line is a sinusoid. In fact, here, very good. So to create a tube, let's drop a tube. What is a tube? I select it, I press A, go in the viewer, we can press W to see the wireframe. So now I see the wireframe. If you pay attention, okay, and actually yes, this connectivity. I love that. Connectivity or only for each cell. I can't. I want to do like only for each. Yes. Okay. So here we see that we do have points. This last point is not attached to the demo, however. Okay. So we see that we can actually replicate a tube with line strips. connectivity, line strips. We can replicate the tube with line strips. So he's happy to be a tube now. So this is the connectivity we need of line strips, so to recreate the tube. Bananas. Okay. We understand something. So to create a tube, the tube must respect the orientation. Right? We do have the possibility to do freaking things with lines and pops, because now the render has two living things in this experimental stuff. So we have pop that are complete shader, basically, that runs on point, vertex, or primitive, or 3D geometry, or any incoming attribute. You don't care much. In the GPU in parallel. Nice. Then I also saw when you start as designer, there is a thing from NVIDIA, which is, what happened where yeah. Is this, what was it? Primitive, NVIDIA, performance primitive. Yes, picking films. This gets installed when you start the designer. Don't even ask. But this is installed. So we have these two new crazy stuff, a complete shader, the triangle, part and geometry, and this, which is basically how the geometry is sent to the render, I guess. Or there are some other stuff that they're using in pop. Okay, deep dive. With these two magical things, we can then have numerical calculation on those attributes, and we can now freaking use the line metrics. Okay, this guy internally is doing a lot of shit. A lot. All the stuff are generating attributes for us. Those attributes are used later on for geometrical computation. Very nice. What attributes do we need? We have a lot. We care about, and we can run it also about vertices. We don't want this. We want point. What do we need from here? Let's see. I then want to also show you that in this version they have also some stuff in here from pop. It's a bit wild. You can then see the point of the pops and some attributes. So for now, I want to see display attribute dots, and I want to see P1. Okay. By doing this, you have a numerical representation of the attribute, which is the epsilon. I choose it because this line is displaced at the epsilon. So you can see those points here. Those points have a direction. Very nice. And this direction can be also calculated in between those points, like here. Okay. So I can then check direction to next. When I click this guy, if it moves, maybe we have to click this actually. This and this combo allow us to have the direction from this point to this point, and then to this point to this point, and then this point to this point. Why do we need this? Now I show you. We take a circle, which is the other piece of the puzzle. This circle by default is a line strip, and we discover by analyzing the connectivity, then we can represent a tube with circle. And beautiful. The circle in geometry and how we want to deal with stuff and the axis that design epsilon is up. We want to serve it to the copy, so we will use later on in a precise position, which is not only this, which is facing us. We want to have a circle based on the floor. So our floor, okay, like a plate, where you put a plate on the floor. Okay, you want to have it like this. Now it's not like this, you see. To make it as a plate on the floor, let's see. Now it's not. I want to put plate on the floor. Like this. Z, X. You put a plate on the floor. Nice. But we need it as line strip. Okay. Deep understanding. Copy. Okay. Copy of two inputs. Template and something to copy. I want to copy this on this point. I will get it. I know maybe you want this a little bit more or something like that. Right. Let's now analyze the right. Let's stay here. Interactive. You see, we have probably have problems if when the tube curve, because we are not taking consideration the curvature. Nice. Okay, so we want now to take in consideration this curvature. By doing what? By doing this, you will template, rotate to vector, and I'd say, hey, bro, I do not find these attributes you are looking for. We want then to set that our epsilon plus is this guy, okay, and we want to the rotate vector is the direction. Voila. And now we put this circle along a line, respecting the pseudo normal. Let's say that of those lines, you need more than 1 point to a normal, but here we calculated with the direction. Okay, but this is just an amount of points. We are not having faces, okay, or we are not skinning a 3D object. We need 10 division and make it rather small. We are, I don't know, not overlap to so much. That's the way. Okay. There is an operator called skin. What is a skinning operation? These things done in the GPU or actually in the geometrical pipeline. Okay. Skinning is basically doing this. And circle. What we build in a circle. So this is the line state. If you want a surface, you skin the line state. Right. Okay. So we plug this here. This looks kind of active for now because we do not have more than one. But as not normal, so we see this is bad. Okay, because they have no normals. We can inspect. Yes, they have, but they are not being updated. Okay, so since we have them, we can actually delete them, but it's okay. We take a normal, and now below there we have our tips. Okay, I'm going to split the panel, make a geo, make it geometry. Oops, this guy is running. Let's say no, stay there. Okay, ciao. We want to see this guy. Oh, let's center the viewer. Beautiful. So now we create the two topologies, also nice. Okay. If we then animate the pattern, I don't know. If you take a sine and cosine, to make a circle. Circle then has something here broken due to the up vector, which I guess we need to change here like that. So thanks Paqueta, I love you. Like this is the up vector for this setup. So this is the side. Then you can get circle. You can, oops, I don't want to lock it, I want to use it. I don't know. You can work with exponents, then you shrink these strings to build, oops, sorry for that. Noisy table. You can shrink it like that. I don't know, you can build stuff. Okay, beautiful. Yeah, well, let's say now, this is the good thing. Okay, we have one tube on, but before you show me a lot of tubes. Uh, uh, okay, so now we have to take into consideration the skinning operation with a lot of tubes. Let's build them. Let's build them, yes. So we need this here, is our thingy. So it's the build tube. Okay, so we build that tube. Now from here, we want to actually build the tubes online, and I want to drink a glass of water. Okay, I'm back. Okay, so let's build the point we want to trade. Okay. You can take actually anything you like. I will start with point generator. We want to generate point on a circle, and sorry, we need so much, we did not need them on 20 points. Right enough. Okay, then I want to move them so they're not anymore in a circle. So they are different. I could do this in various ways. I will use a mouse. If we now see, they are still kind of the same axis. If you noise them like that, they move. So easy busy. I won't even change the whole thingy. I don't want the noise. We save memory. Very nice. Like here we got the point. Okay, so now I want to rotate those points. So data transform and those beautiful points, we want to rotate them. Let's say we want to rotate in this axis and this axis, like that. You should do something better than uptime, but I'm teaching you something, so I'm using it because I'm lazy. You should not. Alright, let's do it professional. Do it professional. Do it professional, you should always get the timer. Actually, this goes, let's not even more professional. So we take a constant, take two value, we want to rotation. Let's also call it this is x, epsilon. And then you since the rotation is something that loop nice. Okay. And we want also something homogeneous that loop in two different timings. We take the speed jump. In limit, now you loop this guy 0, 3, 60. Okay. So then you have a beautiful I call it route rotation. And then we're super proud because we decide how many degrees we want to rotate per second, basically. Here, this guy. So I suggest you to use prime numbers because it's, I don't know, doesn't make it so often. We use this. And then we have these two things that loop. So they're arranged operation. Tonight. Long term stuff. Okay. This guy are rotating a bit. Let's now trade them. Let's trade. Right. Your lines. Let's plug those lines here. Look. The copy is copying the tubes correctly. Actually, not the last one. Some reason. Let's see. We will avoid it here the video. But then, yeah, then the guide shit. Yeah, bad, really bad. But why is this guy not so more beautiful? Is because we are scanning all the primitives. So it's like a huge amount of stuff. We are telling the render, put a face here and drop a primitive. Bad. Let's solve this. We have some numbers to take into consideration in every primitive. Okay, changes. The number we need to take into consideration is that before trailing, we have a certain number of points. So it's 20. Right? So every 20 point, we want to reach, basically. And since this trailing is an organized set of number, this match the continuous skinning operation you need to do. I don't know if this makes sense in your mind, but if you take 20, you're right there. They are the troops. Basically. I don't know why this last guy is not rotating. Really guy. Come solve this. Attribute. The next. Yeah. Solve it. Okay. We should just use the stress X from the 30p and actually constant for now. Yeah, this is something I don't get very much. Is the last one. Let me check in the other. Pardon, I just checked. So the first point, it's actually, you see here, we have things that is not very much beautiful to see. That is the first point. And yeah, in the trail, you can set the oldest point first. This is making the last part of the tube without problems. But the first one will have this not very beautiful thingy. But we will anyway put an ad here. So let's cover it with something. And to cover this with something, I will open a 0. Yeah, we don't want to work this. Thank you. So we're working with these tubes, and you see we have, we want to put something on the head. Okay. And we'll do also some math with the point. It's very funny. Okay, so I have a powerful GPU. Pay attention that the player can store a lot of points, maybe not in this case, but pay attention. The Windows will freeze. The Vulkan will crash, and you may need to actually turn off your computer. So pay attention. Manually, Windows will froze. So pay attention. I will now tell I want to trail, I don't know, 15 seconds, something, okay? And the cube start to grow. Very nice. I apologize again for the head. I will try to solve this, but let's put something on top. On the head. The head, we can take the position of the head from here. Let's make a branch. A branch. A launch. Let's put them here. Those guides like head point at the toes. Okay. If I simply copy a sphere, is not good. We want to have direction. Okay. You could think, okay, let's use line, but we didn't not have line. Okay. And like finding here the head among those, we could do it with an age, maybe, and then compare the age to get the first Y. We already have it here. Okay. So like in bottom, we can do the same things to find a direction, you cache frame. And we can do so here. So we take a cache top, pardon. Cache. You cache a frame. Okay. So then you cache 3 frames. We are not hungry. We output the last frame, and then we take a math mix. Math mix gives the opportunity to read also the second attribute from the drop down. What you differs from the math combine. So we plug these two guys, and actually we need to plug it correctly. So I want to check the cache. So let's do it again. I want to, oops, okay, in this situation, this is where we want to go. And this is where we pretend to be. So to get the direction. Okay. So I want to know where I pretend to be, where do I need to go? Okay. This is the correct flow. Because then we can say A minus B. And with this A minus B, we want to take the position from the first incoming stream, which is defined as P, and output something called the direction, which will be vector, and then I want to take from the in one, which is the other input, the second one, I want to take P as well. So we're comparing points, but the string of P stay. Nice. In here, we have something called direction. Pop up here the name, direction. Okay, with this direction, we can now copy some cone and orient them. Bananas. Okay, let's take a cube tutorials. We make the cube a cone. Very small. Okay, something like this. Okay. We want to detail and caps. But then here we have non-normals, as I said. So maybe we can put the normal on a point, which is not correct anyway. So we say non-normals, and we want to create them, want to give like a sort of cassette look. So we can then drop a normal and set this breadboard to primitive. So then we have set, and this is flat. This is actually as we expect. Very nice. So then we can copy. We copy the data to a template. Okay, and we'll spin here. Okay. Let's orient them. I want to use Z plus, no, it's example, let's see, don't remember very much. So I have a direction. Okay, how they're oriented. I bet this is always epsilon plus, maybe epsilon minus. Yes, for this reason, epsilon minus for some reason. But yeah, now we have the cone pointing in the direction of the tubes. Beautiful. So make the radius here times more. Something small. Stay small. I think there's 0, 1 now. So what it is. Let's reset the trail. Sometimes you need to. And well. Yeah, by making it smaller, we actually we need to move it a bit forward actually. So yeah, let's make it a tiny bit bigger then. Or we can move it forward. How we can move it forward? We should add a tiny bit. Okay, let's do it complicated. Let's add an offset to the, let's see if I can make it. Let's add an offset. Okay, the theory is that we have a set of points and we have to add a percentage of this set of points to the set of points, so to offset them. I don't know if I explain myself. To do this, this is freestyle. Let's see. I don't know if I will do that. Freestyle. So we take a math mix, the math or even math combine, doesn't really matter. We need to make a copy of A basically. So we take P and we output P with another name, like offset, uh, like p off, something like this. So now we make a couple of p. I want, can I already use it? Let's say if I do 8 times b, can I already use it? Yes. So then this is actually my offset. Okay. Offset. Okay. Because as you said, one, because you're missing the actually percentage. Let's do something more, 0.1. Okay. And we create an offset. Then we want to add the offset to P. A plus B, what we want to add? We want to add P times offset to P, basically. And if we now use this for the distance, we should move them theoretically. Aha, yes, we move them. Okay. So maybe we need to add, should not change P, but the direction maybe. Yes. So then we can move them, I don't know, 0.2, 0.10, maybe on the other side, mine. Yes. Okay, nice, I did it. So now with this offset, you can move them. So if you do minus 30, you move them. We remove them minus 50. I don't know, yeah, you see, you actually move them outside the tube. Okay, so we stay with 10. I don't know, even 30. 30 is too much. 20. Okay, let's say 10 is good. Let's say 10 is good. Okay. Nice. Okay. Sometimes it's flipping, but I guess it's the render. Is the preview only. Anyway, we are in beta. But yes. Okay, nice. To make the tube a tiny bit longer. Right? Very nice. Let's save this project for you. Submarine picture. Okay, it's going long. I make a time break and I'll be back to you. Are you happy to now? Thank you for your attention. Okay, this tutorial is taking kind of long. I hope still with me. Okay, since the second stop repeat. Now, what we wanna do? Yeah. Let's try to avoid this flickering here. This is because the normal are in two separate, let's say, houses. So here we're sending a normal in the primitive, and the tubes have the normal in the point. This is making the preview not happy. So let's find out how we can have the tube with the preset, basically. So we want to generate a normal on the point, and then you want to do a preset with the unique point. And then point, then do way less division. Oh, did not expect that, but maybe there's still a point. Okay, I assume this is a kind of bug of the viewer. Whatever. Let's try to do the last chance by making this some vertex. Still a bit not very much happy, but it's okay. We keep them as they are on point, and we would. But yeah, if you want to have the facet, maybe the operation I showed is worth to try. Okay, let's like render this pretty fast. We want to do not merge it now, because then you create a bigger buffer. It's sometimes not good. Let's make to 0. As always, 1 here, and let's render. Up. The power down. There's the guy. Let's say, yeah, I would just drop a material for everything. So even when you render it, big flicker like this. Okay, let's say we want to output the frames instead of 1. Yeah, these are actually not much. Let me save and open the project. I'm curious. Project. Okay, just reopen the project, and yeah, we do have some problem here. I guess it's a kind of bug, or maybe it's something. Let's put a light. It's something. Actually, when you're there and render it, no, they flicker anyway. This is very much annoying. I guess it's something related to the up vector, which is here. Is constant and should not be constant. Not even up, maybe the direction. Down. Not very much what we want, the normals. I'm using the normal as a vector will do. Yeah, apparently yes. Okay, yeah, we demystify this. Let's see if it's true. Okay, by setting the attribute, they pick it anyway. Okay, very annoying. I hope this will be solved, or maybe I'm miscalculating something. Maybe it's plus and not minus. Well, plus is the word. Whatever. Okay, so we want then to make the line, those line move. Okay. We have the pointer before the matrix. So here we put some noise. And she's doing this. Right. I do prefer to do not output the noise and use Url 3D. So very much doing crazy stuff, and the head position is now this one. So hey, maybe pardon. That position stay that one. And yeah, maybe oh yeah. Okay, so now we have the situation where we have a lot of tubes actually. Okay. And we also put a keyboard in here with so let's set this guy. Then yeah, we can appreciate this. Okay, then you see the noise because we are sending this everywhere is actually also not making the head position match anymore. So it's bad. Okay. So what we're gonna do instead, we want to after the rotation, we want to move them. So we can put it here before the trail. And then you can see that they are kind of following the direction. Okay. And so to smooth down this, we can have a pattern of the size, basically. And then let's say we want to have a pattern, and this pattern is basically a cosine, which is going to do as pattern in all the set of our point. So the start and the end is 0. Okay, so that makes sense. So we can take a pattern here. and we want to output the pattern as a float. Yeah, and the float has to have a name that we call it the size, because we may want to use it later. And we want to reset this. Okay, so now we have a size, and the size is not around, is a cosine. Okay, how to map the amplitude of this with a cosine? You want to map, actually we don't want to map the noise, as always. So as always, I don't want now. So we take the map, we select the attribute we want to use. So the element is size, and we want to map the amplitude of this thingy. It's not actually doing what I was expecting. Yeah, of course. I stopped doing what I was expecting because I need to connect this after to that. And then they do are moving, and maybe the offset is a bit too much now. So I can offset it by 2. And I reset this. And yeah, then we have create lines. There are some imprecision here and there due to the fast movement and the circle, but yay, we got it. Very long, almost 1 hour. Very, very, very long. So yeah, let's resume. The last part was a bit confusing, sorry. So we are rendering this guy. Obviously, we have a lot of beautiful lines, and we did some changes to the position of the point after the rotation. We then create a pattern, which is a cosine, so to set the amplitude. Okay, this amplitude make the first point of the trail as less noise, basically. So they stay attached. You will see it later. Okay, so the pattern now, the pattern now can also be changed from easy up and easy down, so that we can actually see this in action. Yeah, okay, so the pattern now, exactly, we need to set it here in the point scale we want to have size. Yay. Okay, nice. So then we have different size lines while they train, and they should also like grow in time automatically by using this. See. Okay. Very nice. We have random lines going around. Let's save the project. What else we can do? We can go actually very much crazy with colors. Okay. Very much crazy with colors. Okay, so to go very much crazy with colors, let's name stuff. So now it's boring, so we have to name stuff. What is happening here? Here, we don't want to be bored with this. We know it's beautiful. Nice. Okay, so here we're actually creating the head of that. Okay, yeah. And then here we're setting the size of the head. This size, and the size is the size is the amp of the noise. Alright, so bigger are the tubes, more they are noisy. And so then we can apply it here already. The trailer is creating line strips from point Here. Like here we're doing the math. Here we are calculating the direction to to the for now only. It's okay. Okay, this is because we are lines. In here we are calculating here we are calculating what? As only here. Okay. Actually, yeah, also this guy, is applying the distance, right? So here we are getting the distance. Okay, distance. No, not the distance. You see the head direction. Come on, head direction. No, yes, we have the head direction, and this is the offset. Oh, right, right. Now let's say it again. Yeah, just to remind, let's think a constant. Think a constant. That's will tell you like that. You want the channel first volume, and this is all the capitals. Nice. We break it. It's okay. Let's read right here offset. False. So then the offset can be like 1 2 while we would. And then we are actually creating the head. Put the head. Put the head. Okay. No, solid. Pork. But okay, nice. And this is then the render. I won't spend much time on it. Yeah, we rendered it nice. What is this? This is the boxes and rendered a linear. We are like make cubes. Nice. Set up a lot of stuff. Just give a tube example. Okay, nice. We are missing a magic with the tubes, with the color. Right. So let's create a color. The color we created. We can create it before everything. Right here. Let me create that color. I don't know why I like it really this. Let's see if we can do smart. Maybe we can do just a noise. Look at that. And if I say, you don't want to do stuff, but instead call it noise, call it color, and then said because we need a ref for. Nice. So theoretically, I do am assigning some color to those pointers also, because now we can go in this page of the copy, enable this and set this to color. Okay, so we're noising also the alpha. This is bad actually. This is bad actually. So what if I do this? Right kind of this, right? Same. And it's okay. Okay, now we can do it this way. So you see, if I put a background, then should noise, yeah, you see, yes, done that for me. If I put the background, yeah. Like this. You see, they're also noising, that's correct, or, and, oh, yeah, I'll do that. Let me, do trade again. Okay, now we see we have slight colors. So if I can then noise this even more, we should theoretically, yes. Okay, it's working. We can directly apply color by naming the attribute here. Nice. Okay. So then we have this. Okay. Colored lines. Achieved. Very nice. So after we create those beautiful colored lines, what we want to do, we want also to put the same color to the head. So this is the challenge. We can do this. We can do this with a lookup attribute set up in a really, really smart way. Okay. We then need to activate the superpower of the template attribute per point on these guys with the head. Or this guide now is how to is creating the template attribute that by saying that the let's see if we need to do this a lot. So in the trade, we have the possibility to set should have the possibility, yeah, here, the oldest point first. Okay, now set it to true. I don't know if it's correct. Let me see. Because this is actually matching the template ID from these two. So the first one should have the same template ID of this one. It's useful because we can then do a lookup attribute. Okay, that's it. We want to, the stream of the geometry is this. So, okay. And the attribute we want to read, it's among in this mesh. It's in, does it matter? We should take it from here. Doesn't really matter, actually. That's, I hope so. Okay, so now we have the template attribute here. How to use? We want to first, not first, tell that you have the template attribute. Yeah, on point. So then we can use it. So both copy of them. I can then set it here. And you need to be point index. Okay. The value we want to read is the value we want to read from the string is color and want to put it as color. Okay, so theoretically now, if we see those, they should have the same color of the tree they're leaving. So it's very cool. Yes. Nice. Okay. Since we do have some blending, we should do this. Not because the alpha maybe is not one. Can go lower. Do this. Like that. Okay. So we built some beautiful cubes and we learned a lot this time, second 1 hour lesson. Okay, so have fun. Please support my work on Patreon. This will be shared. And yeah, thank you for the attention. Ciao, my friend.